Okay, in this video episode, I'm going to show you how to use the remainder theorem in order to find the remainder of a particular division process. Now, there's two ways you can find the remainder. There's the long-winded extracted process of long division, and then at the end you come up with the remainder. Or there's the quick, simple, and efficient way, which is part of the remainder theorem, where you do just a simple substitution, where you can come up with the remainder quickly. And that will tell you things like whether or not the divisor is a factor or not of that particular polynomial, and it's a very quick and efficient way. So let me do it both ways. First of all, just to give you a bit of contrast, I'm going to do it the long-winded, long division way, and then we're going to use the remainder theorem. So what do we have? We have 8x plus x squared plus 3 is going to be divided by 3 plus x. Now, the first thing you might want to notice is I wonder whether you can see that they're not in descending order. If you're going to do long division, it always pays to put it in descending order because they rearrange. You'll notice the 8x is here, the x squared is in the middle, the constant 3 is over there, and this is kind of reversed. We've got the constant on the left and the x value on the right. So let me do the long division method and I'll put them all in descending order. Okay. Polynomial right here, I'm going to put the x squared first, x squared, and then we'll put the plus 8x and then the plus 3. That's also referred to as the dividend. Let's get the divisor. I'm going to swap them around, put the x on the left, x plus 3. So what's our outcome? The objective is to find the remainder once this divides into that. Now, if we do get a remainder, that means that this divisor is not a factor of this polynomial right there. Okay, let's go through the process. Now, it involves 3 simple steps. You've probably heard this in other videos. First, we divide, then we multiply, then we subtract, then we repeat that process. So that's the long division. Okay, let's go through it again. So let us divide. So how many times does x divide into x squared? It goes in x times. Then we multiply. X times x is x squared. X times 3 is plus 3x. So let's subtract now. All right, x squared minus x squared is 0. And 8x minus 3x, that gives us 5x. Let's drag and drop the 3 down here. So that's going to be plus 3. Let's go through it again. Divide, multiply, subtract. Okay, x into 5x goes in plus 5 times. Let's multiply. 5 times x is 5x. 5 times 3 is plus 15. Now we subtract. Okay, 5x, take away 5x is 0. 3 minus 15, that's going to be negative 12. And there you have it. After all that work, we came up with the remainder equals negative 12. Okay, let's do it a quick and simple, efficient way, the remainder theorem. So we're going to do the same process, and we're going to come up with that very quickly. So this is what we do. We're going to substitute this particular value in there, and it works like this. We're going to go px, or function x, or polynomial x, is equal to, let's write it in descending order, x squared plus 8x plus 3. Now, because we got this guy over here, the divisor, that's going to be p, polynomial, to the power, well, we're substituting, that's x plus 3, so therefore we put minus 3 there. It's negative. If that's a plus there, it'll be a negative. That's what we're substituting, that value in there. So that's going to equal negative 3 all squared plus 8 times, you guessed it, negative 3 plus 3. We're looking for that remainder now. That's our outcome, remember? Okay, p negative 3 equals negative 3 squared gives us a positive 9 plus negative 3 times 8, that's going to be a negative 24. So that's negative 24 plus 3. All right, let's add these two guys. 9 and 3, that's going to give us 12. So we have 12 plus minus is a minus, minus 24. Therefore, P negative 3 gives us a value of 12 minus 24 equals what? Negative 12. So that's our remainder again. So P negative 3 gives us the remainder. As you can see, it matches minus 12 minus 12. There you go.